In this video, we'll go over the beginning of our ANOVA calculations. So we'll go over 3 sum of squared deviations calculations that are needed to calculate the F ratio. So to do an ANOVA, an analysis of variance, we have a total of 9 calculations. So the final goal is for an F ratio. We've discussed this. This is the variance between treatments over the variance within treatments, or the variance accounted for by the treatment effect plus the variation that would be expected based on having individual differences. And this is our variance that would be expected based on individual differences or error. So each variance within the F ratio is computed as sum of squared deviations over degrees of freedom, just like the variance we were calculating before, that S squared. So to do a between variance, between subjects variance, we need to take the sum of squared deviations for between groups over the degrees of freedom for the between groups. For our variance for within our treatments, we take the sum of squared deviations within our treatment groups over the degrees of freedom within the treatment groups. Now, to get these sum of squared deviations and our degrees of freedom, we have some more calculations. So we have a sum of squared deviations total, which can be split into between and within. And we have degrees of freedom total, which can be split into between and within. So we start off with 3 sum of squared deviations formulas. It says total, between, and within. And I'll show you some different ways in this video of how to calculate those. We have our 3 degrees of freedom formulas. We have 2 variance formulas. And we have 1 F ratio. So partitioning our sum of squared deviations for the independent measures ANOVA. So we have this total, and this is a formula for the sum of squared deviations, the total experiment. Here's sum of squared deviations for between treatments. And here's a formula for that. And then the sum of squared deviations within treatment is the sum of the sum of squared deviations inside each treatment. So we have, within each treatment, we'll get a sum of squared deviations. Then between the treatments, we'll get a sum of squared deviations. And those added together give us our total. All right, so back to the example from the previous video. We know that K is 3, meaning we have 3 different treatment groups. We have an N of 5 for each treatment, so that small n is the number of individuals in a given treatment. The big N is the number of individuals in the entire experiment. G is the grand total of all scores in the study, which is the sum of T. And T is like our sum of X, so it's the total in a treatment group. So the formula for sum of squares total, for the total sum of squared deviations for the total experiment is very similar. It looks very similar to what we've seen before. It's the sum of X squared, which we calculated previously. Then you take G squared, because that's like the sum of X, over big N. So we did this in the previous video, but I'll do it again just for demonstration purposes. We want to get X squared for each of our treatments. So 4 squared is going to be 16, 9, 36, 9, and 16. And that's going to give us a total down here of 86. And 0, 1, 9, 1, and 0. It's going to give us a total of 11. We have 1, 4, 4, 0, 0. It's going to give us a value of 9. So going with our normal sum of squared deviations formula, for each treatment. So remember, T is kind of like our X, right? So we're going to take the sum of X squared for sample 1, which would be 86, minus our T, which was 20, squared over 5. So it'll give us 86 minus 80 is going to give us a value of 6. So our sum of square deviations for sample 2 is, again, we're going to take our x squared, which is 11, minus our t squared over n. Oops. It's going to give us 11 over 25 divided by 5. 11 minus 5, or 6. And for sample 3, our sum of x squared is 9 minus t squared over n, which is 5. It's going to give us 9 minus 5. It's going to give us 4. So then let's do this calculation for the sum of squared total. So we're going to take the sum of x squared, which we calculated previously as 106. We took 86 plus 11 plus 9. So total is going to be 106 minus g squared, so this is our g value, so 30 squared over big N. So big N is 15. So 106 over 900 divided by 15, which is 106 subtract 60, which gives us 46. So that's our sum of squared for the total experiment. To calculate our sum of squared for sum of squared deviations within the treatment, we need to add up the sum of squares inside each. And we said that these were 6, 6, and 4. We had previously calculated those just a little bit ago. So to get our sum of squares within, we're going to add up 6 plus 6 plus 4. And remember, we got these numbers just a few minutes ago by using this formula. So this is the sum of squared deviations for sample 1, the sum of squared deviations for sample 2, and the sum of squared deviations for sample 3. We add those all up to give us 16. So now we know that this value we calculated, and we found it to be 46. That's our total. We calculated this value, and we found it to be 16. Now, there's a couple of different ways we can get our sum of squares between. So if we know that our sum of squares total is partitioned into within and between, the sum of those two values is going to give us our sum of squared total. So we can work the formula. So we know that our sum of squared total is 46, and our sum of squared within is 16. So the total is 46. Sum of squared within is 16 plus the between. That's the value we don't know. If we subtract 16 from both sides, this cancels out, and that gives us 30 equals the sum of squares between. Here's another way of doing that. And then here's a third way of doing that. So let's go ahead and try this other formula. But we don't know what our sum of square means are. So that means the sum of square deviations for just those 3 sample means. So let's consider those almost like an x value. And in order to get do my formula, those values. This gives me the sum of the means is 6, and the sum of the mean squares is 18. So 18 minus 6 squared over how many means do I have? I have 1, 2, 3 means. So it's not the n that's up here. It's the number of values I'm calculating. So it's going to give us 18 over 12, or minus 12, which gives us 6. So now our SS means equals 6. So we use this formula for between. Now we're going back to the n for what's within our treatment, which is 5. And we take our SS means, which was 6, and that gives us 30, which is also what we had on the previous slide. So there's also another formula. So to get the sum of t squared over n, we need to take our first t value, 20, square it over n, add our next t value, which is 5, 5 squared over our small n, plus our next t value over n. That's going to give me 80 plus 5 plus 5 gives me 90. So the sum of squared between, it's going to give me 90, subtract g squared, 30 squared over big N, which is 15, (90) minus 60, which gives me 30. So all three ways we've gotten the same value. Now, obviously, some of them are more difficult than the others, but it just depends on what information you're given as to which formula to use.